kan, kalau aku punya level sikit daripada ni.
Okey, cuma dia macam masa dia cakap dia tunggu habis macam tadi Israel tu pun dia satu-satu cakap dia tak nak ada interruption lah. Dan kalau soalan
Okey.
soalan daripada audiens ni dia galakkan soalan bertulis lah dekat chat.
Okey.
Because kalau ada soalan nak tanya tu dia tak nak sekadar orang terlampau lama on bagi pendapat. It's not
Okey.
soalan. So dia cakap.
Okey. Okey.
Okay, nanti Amli cakap lah, cakap the audience kalau nak tanya soalan lepas session nanti dah habis session discussion tu.
Okey.
Kita encourage semua tulis dekat chat room lah.
Okey.
Kita copy macam tu lah.
Alright, I will tell that.
Okay.
Okay. Nazri. Rabah calling Nazri, come in Nazri.
Yep.
Ini pun sama kan, apa ni, IEEE sensor nano.
No.
No,
tak ada. Tak ada.
Oh, tak ada. Okay,
Ya,
alright.
yang kita
Okay.
pakai puli kita punya ni.
Okay, alright.
Yep.
Ladies and gentlemen, I see a certain Faiz Shahimin here. And your profile picture is looking something similar to somebody I used to know.
Dia punya adik lah.
Betul kah?
Ya.
Alright.
Hopefully Vin akan masuk because dia minta kita postpone on 10 o'clock due to dia punya flight schedule lah, dia baru landing somewhere near New York lah, so dia minta one hour postpone lah.
Oh, okay.
Yeah, so dia boleh join.
The display like before doesn't come out like before lah. Yang tadi memang tak display eh?
You mean ini map video semua tu?
Kalau dalam live streaming ada. Tapi kenapa Syah? Kenapa tak keluar kat sini? Tadi keluar.
Kat Zoom tak ada.
Syah. Kenapa dekat Zoom tak ada promo ISIS? Kalau dalam live streaming ada. Okey, dah ada.
Maybe we have to pin the video ourselves. Sorry.
Okey. Vin dah masuk ni, dah boleh keluar balik.
No, Vin is
Oh, yeah, he's here.
You hear me?
Okey.
Okay.
So hi Vin.
Hello there.
Ya.
Is the audio okay?
Ya. Okey.
Slightly echoing.
Super. Oh, it's echoing. Well, I'm not sure what to do about that.
Now it's okay. Now it's okay.
Yeah, now it's okay.
Yeah.
Okay, this is probably, there's an echo cancellation algorithm and it takes a minute to
Okay.
get
Okay.
it into effect. So if I've understood correctly, this is basically a Q&A thing as opposed to a presentation. Is that right?
Yeah,
Yes.
actually, yeah.
Okay, that's great.
I think it's just the same like we discussed before Vin.
Really, if you don't mind me asking, is it Cerf or is it Cerf?
Surf.
Surf,
It's French. It's not Italian.
Okay,
If it were
okay.
Italian, it would be Cerf.
Yeah, okay.
And whenever I'm in France, they always say surf, and they expect me to speak good French, which I don't. And when I'm in Italy, it's Cerf. And when I'm in Germany, My first name is Vint, but the Germans know that the V sound is a W.
Yeah, correct.
They always call me Wint instead of Vint.
Vince. Okay.
It's very funny and it's very consistent.
Very consistent. Okay. That's a good tongue twister there. Different nations. Nazri, how? We will wait a bit more or?
Yes, well, I'm assuming we have a few minutes before start time, but I wanted to log in and make sure everything worked okay.
Yeah, yeah. Everything's okay on our side, on your side. You look good too.
So I think we can start now.
Okay. Alright, I'll start now. Okay. We'll just give me a few minutes to read out some things.
Sure.
Okay. Salam sejahtera, selamat pagi, and a very good morning to all gathered here virtually. We are here for International STEM and Innovation Colloquia Series 22, which is a great thank you to the efforts of Drs. Nazri Halif and Sharif Faiza, as well as UNIMEF Vice Chancellor, Prof. Saliman Sauli, and Deputy Vice Chancellor of Research and Innovation, Prof. Rizal Fandi, their respective officers, and the broadcast control team here, led by Mr. Sharizan, for hosting this event. I'm Prabha, the moderator for this ICIS Series 22. Before we begin, as is normal, I would like to introduce our esteemed speaker for this Series 22, Dr. Vinton Cerf. We wish you a very good evening, Dr. Vinton. Vinton G. Cerf is Google's Vice President and Chief Internet Evangelist, where he helps guide global internet policy and development. Often called one of the fathers of the internet, he co-created the TCP/IP protocols and helped build the internet's foundation. Cerf has held key roles at MCI, DARPA, Stanford University, and the Corporation for National Research Initiatives. He chaired ICANN from 2000 to 2007 and has been a visiting scientist at NASA's JPL since 1998. From 1992 to 1995, he was president of the Internet Society. He is a member of the Royal Society and the Swedish Academy of Engineering and a fellow of IEEE, ACM, and other major organizations. His part of his many honors include the US Presidential Medal of Freedom, the National Medal of Technology, IEEE Medal of Honor, and the ACM Turing Award. In 1994, People magazine named him one of the 25 most intriguing people. Intriguing, I'm intrigued now. If anyone wishes to ask anything, hope you do not interrupt Vint during his talk. It would be better if you could type it at the chat box. Thank you. Dr. Vint will talk on a questions basis. Vint, before we begin our discussion, would you like to say anything?
First of all, thank you very much for inviting me to join you. It's a little late here I'm in Ann Arbor, Michigan. I'll be preparing to give the talk tomorrow at the University of Michigan. And so it just happened to fit in. We arrived not too long ago. So I'm happy to have this opportunity to answer questions that people might have and to try to share to the best of my ability my experience with now almost 50 years of internet.
Okay, thank you, Dr. Vint. Shall we start? Okay, my first question is, the internet was initially designed for academic and military use. Why or what was the need for this interconnection of institutes in the first place?
So it turns out that the internet's story begins in the late 1960s when what was then called the Advanced Research Projects Agency was funding research in artificial intelligence. And I think this is important to note that AI studies have been around for over 60 years. The first introduction of that term AI was in 1956 by John McCarthy at a conference that was held to discuss the possibility of computers becoming artificially intelligent. So ARPA was funding research at a dozen different universities in the 1960s. And every year, each university kept asking for a world-class computer. And ARPA said, we can't afford to buy a dozen world-class computers for a dozen universities every year. So we're going to build a network, and you're going to share your resources and advance the state of the art as quickly as possible. Of course, 60 years later, we discovered that it took a long time to really advance the state of the art. But the first network that was built was called ARPANET, and it was a big experiment in packet switching, which at the time was considered a very risky proposition. People who were accustomed to providing conventional telecommunications thought in terms of circuit switching, which is how the telephone system worked. But that would not have made a whole lot of sense for computer interconnection, because computers spit things out to multiple machines, one after the other. Having to set up and tear down circuits would have been a very slow process. So the ARPANET was used in an academic setting to link these various universities and very diverse computers from different computer makers. This experiment was so successful that it was demonstrated publicly late in 1972. And shortly thereafter, in the spring, my colleague, Robert Kahn, went to ARPA and then joined me at Stanford University and explained that the Defense Department wanted to use computers for command and control. But in order to do that, they would have to have mobile communication for vehicles, for ships at sea, and for aircraft. So he started working on both a packet satellite network and a packet radio, mobile ground packet radio network, to join the ARPANET, which was based on dedicated telephone circuits connecting the packet switches to each other. So when he got to Stanford in the spring of '73, he basically put the problem on the table. How are we going to connect these different kinds of packet switch networks? That was the internet problem. So the same people that had helped to design and build the ARPANET were drawn into helping to design and build the internet. So it has its origins in the academic community. Its creators and its users were mostly in the academic world. But the motivation was to design something that could eventually be used as the core of a command and control system for the Defense Department. So in these early days, in the early to mid 1970s, we were considering how to do packetized speech, packetized voice, email, and file transfers, and all of these things that would be required for command and control. We were trying to do in this multi-network environment. So this all had made good sense. Bob Kahn and I released the design in 1974 publicly because we knew that the American Defense Department would need to have a common set of protocols to work with its allies. And of course, the allies of the time in the mid-70s were different from the ones in the 40s, and we didn't know who they were going to be in the 80s and 90s. So we just released the design publicly to make sure everybody could have access to the design of the protocols. So you asked, I think, why these institutes were connected. It was primarily initially to do artificial intelligence research. Then it became a focus of attention to design a network for command and control for the Defense Department. So, but it was being used, implemented, and used in the in academic setting. So that's why we ended up, with a lot of universities engaged in building this multi-network system. And of course, it was of interest from the research point of view as well. Because there were very different ways of using packet switching, and they were all different. They had different data rates, different addressing structures, different protocols, and we had to figure out how to make it all look uniform. And that's where the transmission control protocol and eventually the internet protocol emerged as the mechanism by which all of these different networks and computers could look like one common system, which today we call the internet.
Okay. So it's basically more towards defense command and control.
That was the original motivation for ARPA's funding of the work. Of course, as we all know, it eventually escaped from its laboratory and became publicly available in 1989. And by that time, we had multiple networks that had been built by the American research community. The Department of Energy, NASA, and NSF joined ARPA in building backbone networks using the TCP/IP protocols and then connected them all together. And that led to the connection of thousands of universities to the National Science Foundation backbone network. All the laboratories of NASA and the Department of Energy were connected together and connected to the universities. And all of them had access to the supercomputers that the Department of Energy and NSF were funding. So even in the mid to late 1980s, we had a substantial growth of the system with these different backbone networks all being built by government support. What the transformation into publicly available services comes around 1989, when 3 commercial internet service providers popped up in the United States, 2 of them in Virginia, UUNet and PSINet, and one in California called SurfNet. And they interconnected themselves together as commercial entities, and then they were interconnected to the network of the academic networks that had already been built. And so by 1991, we had a very rich networking environment in the US. It's starting to spread to other parts of the world, especially in Europe. And around that time, around 1991, Tim Berners-Lee comes along and releases the World Wide Web out of CERN in Geneva. And not too many people noticed at that point, but 2 years later, there were 2 researchers at the University of Illinois, the National Center for Supercomputer Applications, and they built a browser that was based on a graphical user interface. They called it Mosaic. And that was an improvement over the text-based browser that Tim Berners-Lee had offered in 1991. And they made that freely available. And of course, lots and lots of people downloaded that in the academic world and also in the commercial world. And so one of the founders of Silicon Graphics took one look at the Mosaic browser and said, holy cow, this is a big deal, and brought Mark Andreessen and Eric Biena to the West Coast to start a company in 1994 called Netscape Communications. They went public in 1995, and the stock went through the roof, and that was the beginning of the dot boom, where investors were throwing money at anything that looked like it might have something to do with the internet. And of course, the dot boom went on for 2 years, and then it went bust in April of 2000. A lot of those companies.
Wait, just hang on.
Yeah.
Shah, can you mute this whole Ruiz one?
Is there a way to turn
all right.
off their video?
You have muted. Okay, sorry about that.
Okay, well, that's all right. This happens. It's not the first time. So the important thing is that the dot boom dies in April of 2000, but there were a number of companies that were created during that boom period that survived. One of them was Amazon, which was started in 1994, and another one was Google, which was started in 1998. And they both have done very well. They have survived and thrived. And of course, so has the internet over that period of time. From the early 2000s to the present, over the past 25 years, the internet has spread across the globe. About 2/3 of the world's population have direct access to it. I know that's a very long answer to a very short question, but that brings us to the present, where the internet is broadly available. The smartphones came along in 2007 from Apple, the iPhone. And that expanded access to the internet to anywhere you could get a signal from the 4G or the 5G system. So that has enhanced the number of applications that people have available. And of course, social networking came along, and now artificial intelligence in its third incarnation is very much with us.
Where were you when all this was happening? When you said you released the what do you call it, the protocol, when you made it
The TCP/IP protocol. Well, in '74, I was at Stanford University,
okay.
and Bob Kahn was at ARPA, and we collaborated on the design of TCP. And then in 1976, I joined him at ARPA. And from 1976 to 1983, roughly, I stayed at ARPA, worked with him, and led the research program, the internet program, packet radio program, packet satellite program, packet security program. And then after 6 years at ARPA, I joined the private sector, MCI, the first time to build a commercial email service called MCI Mail. And then in '86, I left MCI and rejoined Bob Kahn at his new research organization, the Center for, or the Corporation for National Research Initiatives. And we spent 8 years together exploring all kinds of potential applications of the internet, things like digital libraries, for example, and knowledge robots that were mobile software code moving around in the network, carrying out tasks for people, which sounds very much like today's agents in the AI space, although we weren't using what we would recognize today as AI technology. It was a lot more conventional software. And then I returned to MCI in 1994 to put them in the internet business. And so we built 2 internet backbones, commercial backbones, during that time. And so I was at MCI during the dot boom period. And then after the dot bust happened, I ended up around 2005 joining Google, and I've been there for about 20 years now.
Did you ever think? Did you ever imagine that you would be joining that?
Well, I kind of wish I had joined them a little earlier.
Oh, okay.
I joined them in 2005, and they went public in 2004. And it would have been slightly better. I'm not complaining. They treated me very well. But it would have been slightly better if I had joined them before they went public. But I joined the year after that.
Okay. All right. Did you ever anticipate the rapid evolution of the network at that time, from being into a global commercial and social infrastructure?
Well, I don't think that any of us anticipated how broadly internet would penetrate, the general public. But we were doing things even in the early days of the internet and the ARPANET that are not unlike what we're doing today. To give you an example, in 1971 or so, a man named Ray Tomlinson suggested network email would be an interesting application. And of course, as soon as he released it, we all got email addresses. And very quickly, we created mailing lists. And some of them were, well, the first one I joined was called Sci-Fi Lovers, Science Fiction Lovers. And we had big arguments over who were the best authors of science fiction. That was very social. And then the next one I joined was called Yum Yum, which was a restaurant review distribution list for restaurants in the Palo Alto area near Stanford University. So we were already seeing social networking in a very crude sense literally over 50 years ago. So some of the aspects of today's internet were visible back in those periods, but simply not at the same scale. On the other hand, remember that Bob and I were persuaded that we needed to do packet speech and packet video in those early days because of the command and control requirement. Of course, today we're doing what we're doing right this moment. And the only reason we can do it is that there has been an enormous growth in the capacity of the network. Optical fiber networks spanning the globe, data rates on the order of 400 gigabits a second per optical channel, which was unthinkable back then. The ARPANET backbone was only 50 kilobits a second, and the NSF backbone was 1.5 megabits a second. which seemed very fast at the time. And of course, today that would be a snail's crawl.
Since you brought up a few names. Hello, Shafrudi, please.
NOR.
Shafrudi. Muhammad Shafrudi.
Yeah, sorry.
Please mute yourself. Thank you. Since you brought up some interesting names, may I ask if they're still around? MCI, Netscape.
Well, Netscape is not around and MCI is not around, but Amazon and Google survived.
Yeah, Amazon, Google, yes. Okay.
Actually, MCI was reincarnated. It was acquired by Verizon, which is another telecommunications
yeah, correct.
company.
Yeah, correct.
So the networks and the people went to Verizon, and as they were going to Verizon, I was going to Google in 2000.
Okay, so parts of it survived in that manner.
Yes.
Okay. Only Netscape went bust.
Netscape went bust. That's true.
That's bad. Okay. Okay. Looking back, what were the biggest technical or conceptual challenges in the early development of the internet, and how did you guys overcome them?
Well, the technical challenges were basically nobody had ever done this before. And so we were, trying things out and didn't necessarily know for sure what the right solutions were. So we had a very open experimental environment for the internet. And it took us from 73 to about 78 or so to try to settle on a design. We had went through four iterations of the TCP/IP protocols, for example, before we stabilized them. And then starting in 78, we started getting implementations on as many different operating systems as possible, because in those days, there were a lot of different operating systems, unlike today, where it's Unix or Linux and a few others, iOS, for example. We spent a lot of time implementing the protocols in different operating systems, and then we had to deploy it across the internet for all of the host computers that were on the ARPANET, which was the biggest of the networks, as well as the packet radio and packet satellite nets. So that turned out to take some time, and it wasn't until January 1 of 1983 that we turned the internet on operationally. So that was a 10-year period from 73 to 83. Meanwhile, in 1978, after we had just frozen the TCP/IP protocol suite, some of our colleagues in Europe decided that they didn't want to use this military development, and they started a new program called the Open Systems Interconnection, or OSI. And that was being standardized through the International Standards Organization. So for about 1978 to 1993, TCP/IP and the OSI protocol suite were essentially competing with each other for which one would become the international standard for internetworking. And as it turns out, the TCP/IP protocols were implemented and distributed more rapidly than OSI. And so by 93, it was pretty clear that the TCP/IP protocols were broadly enough available. The internet had been operational for 10 years, and the OSI protocols sort of sank into oblivion. There was a good contribution, though, that came from that effort was architectural layering and labeling of the layers and the functionality of the layers. So that work was often used as an academic framework for describing how packet switch networks could work. But the actual implementation and choice of protocols turned out to be the TCP/IP.
Let me digress a bit. I'm curious to know your role. Was it as a researcher from Stanford, or on a grant basis or research program, or was it contracted out to develop this thing?
So in my early work at Stanford University, it was funded by DARPA, and it was research. It was to develop the protocol suite, to get it implemented and tested. And of course, as I say, we iterated on it. I joined ARPA to run the program in 1976, and we were still in two more iterations from before 1978 to freeze the protocols. So I went from being essentially a researcher leading the research program to program manager at ARPA, running multiple programs, all using the internet and expanding its functionality. In particular, all three of the networks, ARPANET, packet radio, and packet satellite. Incidentally, in the same time frame, 1973, the Ethernet was developed by Bob Metcalf and David Boggs at Xerox PARC in Palo Alto. And so they were around the corner from my lab at Stanford. And they too were yet another high-speed packet switch network. And we brought them onto the internet as well by way of a packet radio system housed at Xerox PARC, connecting a bunch of Ethernets to the rest of the what was then the three-network internet. So you had asked a little bit about what problems we had, and I would say one of them was the competition. And I didn't even mention the 1976 standards called X25 and X75, which were yet another internetworking protocol suite coming from the International Telecommunications Union. So there were three competitors. Here we go again.
Yeah, Rosino. Hello, Miss Rosino. Rosino.
We have.
Hello, sorry, doctor. I just
Okay. All right.
We have a problem with microphone discipline here. So there were three competing protocol suites before TCP/IP went out, and I think the biggest and trickiest problem was the move from a purely academic environment, or one which was supported by the Defense Department, to a commercial environment. And that begins in 1989. The commercialization of both the network service and the equipment and software needed to run internet. For example, Cisco Systems gets started in 1984. Sometime later, Juniper is another router company, came along. And so trying to draw attention to the availability of this technology in the commercial sector required yet another institution to be created. It was called Interop, which stood for interoperability. It was created by a man named Dan Lynch, who had been part of the internet development in its history. But he set up an exhibition that allowed people to come and see how the internet could work and how different systems would interwork with each other on a very large scale Ethernet. So the visibility in the commercial sector was very essential to the internet's growth and access by the private sector and the general public.
Did this commercialization in any way piss off the Defense Department?
Well, the Defense Department actually benefited from the commercialization in two ways. First of all, things like routers and software for host computers became available just by purchase order. You know, they didn't have to go build and maintain it themselves.
Okay.
Buy it. That was a very powerful, I would say, incentive for the government, not just the military, but all the other parts of the government. So commercialization is your friend here, because it's driven by not only the requirements of the research and military community, but it's also driven by the commercial sector, which is infinitely bigger, especially on a global scale. So that was a beneficial outcome. And I pushed very hard for that. I believed that it would be beneficial to have this available to the private sector and the general public. Although I have to confess to you that some of my colleagues in the research world were not very enthusiastic about the general public getting into their sandbox. But several companies went commercial with services, like I mentioned earlier, three of them in the US. And of course, the rest is history, because it's certainly become a massive enterprise all around the world.
Okay. Going slightly a bit off now, with growing concerns over misinformation, cybersecurity, cyber policing, online taxation, and digital divide, do you think the original vision of an open, free, and decentralized internet is still available, sustainable? What would you change on hindsight?
Well, it's painful to recognize when a technology like the internet can be abused by people, and it is abused. There's no question about it.
Yes.
Misinformation and disinformation spread, malware, cyber attacks of various kinds, denial of service attacks, phishing attacks. There are all kinds of bad things that people do, in addition to the very good things that this platform is capable of supporting. We didn't see those bad behaviors until the network became publicly available. And so I suppose you could argue that that was a bad side effect. On the other hand, I would argue that it also has had tremendous value. Many new businesses have been formed. People have become educated by access to online resources. All you have to do is look at YouTube, for example. You see people typing, how do I do X for some value of X? And there's somebody that's already done a video explaining to you how to do that.
Yeah.
Research, of course, has benefited dramatically from being online. We'll get to the artificial intelligence topic in a moment, but just to reinforce the point, one of the most spectacular results in research from multi-layer neural networks is the recent development of what was called AlphaFold, which is an AI tool that allows you to see what the shape is of 200 million proteins that can be generated by interpreting DNA in the human genome. All 200 million proteins are now understood with regard to their shape, and that gives us some clue as to their functionality. That was a dramatic result, but it only worked because a lot of the training could be done in an online environment. The same can be said for large language models, which are trained on content which is found throughout the World Wide Web. All of those benefits would not have happened at all if it weren't for this gigantic platform filled with content. But we still have to deal with the bad stuff. So although it used to be a popular notion that anonymity was your friend in this online environment, I think that's less true now. I think that under the right circumstances, we have to penetrate the veil of anonymity to hold people accountable for their bad behavior. So governments around the world are looking for ways in which to cooperate in order to make this a safer environment. One of those avenues is the Global Digital Compact, which was realized at the United Nations literally last year, among other agreements that are being pursued. So I would expect during the rest of this decade, you'll find countries cooperating with each other in order to hold parties accountable for their harmful behavior online.
On a similar line, Vin, there are a few questions on the chat box. I'll read them now, is okay?
Yes, I'm happy to look at those.
All right. Since the internet was built on the spirit of open protocols and open source collaboration, would you agree that the internet is today's version of the printing press, democratizing information and ideas at a global scale? And it's the reason we are at an unprecedented scale of technological progress.
Yes, I would agree with that analogy, but I would point out one other thing that's even perhaps more salient. The fact that the information is in digital form means it can be both consumed or generated by computers, by software. And the consequence of that is that we have powerful tools for using this content in ways that we could not do before with just paper-based material, because that had to go through somebody's eyes and into their brains. The digital content can be consumed and used by software, which is exactly what's happened with artificial intelligence. We have computers consuming content and using it to train themselves to be a collaborative tool. for people who would like to exercise the large language models or other machine learning tools in order to be more efficient in doing their work.
Okay. Continuing that would they. Okay, you provided an open protocol for the internet and building the internet in an open environment. In contrast, many traditional industries such as art, manufacturing, oil and gas still operate largely in closed proprietary ecosystems. In your view, should these industries move toward more openness? What would they stand to gain or lose by doing so?
Well, the obvious thing is that as you build more uniformity into the system, standards, for example, then you allow for interoperation that would otherwise be very difficult to support. And if you toss in artificial intelligence into the mix, you begin to see ways in which computers can do things that instead of human beings having to do them. Or you accelerate the pace at which humans can do their work because the computers amplify this capacity. And I can also imagine that automation will become helpful in most of those industries. We're seeing this happening in all dimensions where computer-based systems are, well, look at automobile construction, for example. If you take a look at the Tesla manufacturing plant, is full of robots that are assembling the cars. Yeah. And we're seeing an increasing attention being paid to that sort of automation. So I'm persuaded that we will see a lot of the traditional industries integrating more and more computer-based capability over time. And of course, some people will say, well, that means the old jobs will go away. And this is a true statement for many kinds of work. But this also happened during the Industrial Revolution.
Yes.
People went from handcrafted things to machine-built things. And of course, new jobs came along, like who's going to design the machines, build the machines, maintain the machines, and run the machine.
Correct.
The same argument will be made in this new world of AI and robotics and automation. So there will be plenty of work for people to do. It's just that it'll be different work than they used to do before, which reinforces the notion of retraining and lifelong learning. And so if you will allow me to go on for just a moment on this point, as our lifetimes have gotten longer, our work lives have gotten longer.
Yes.
And the result is that if you have a career that lasts, let's say 40 years, so just pick a round number, or even 50 years, you can imagine how many innovations are likely to happen over that period of time. Yeah. We're going to have to keep learning new things in order to stay relevant. Yeah. And so this whole notion of continuous learning, or at least episodic learning, or just-in-time learning will become central. The idea of going to school for a finite amount of time and then working isn't going to work anymore. We're all going to have to keep learning new things. Okay. And I would say that YouTube is already teaching us a lesson. People go there to learn how to do something they need to do right now. This is sort of just-in-time learning. My carburetor, if there are any of those still left in the world, is broken and I have to fix it. How do I do that? Or how do I use this particular computer-based tool? You will often find a video on YouTube that tells you how to do that. So I'm actually enthusiastic about what's happening, because if it means people get into or become accustomed to learning all the time, or learning new things and wanting to learn new things, that's actually good for our society.
Yep, thanks, Doc. Another question there, a relevant one to one you brought up. Since you mentioned X.25, what is the reason why people, except for the aviation industry, to move from X.25 to TCP/IP?
Well, there may be a couple of reasons for that. The X.25 protocol was very successful, by the way, especially in the banking industry. But the TCP/IP protocols ran over everything. It didn't matter what transmission technology you were using, we could make it work. And X25 was a circuit switched, a virtual circuit environment. The internet was a datagram environment which offered more flexibility. And in particular, it allowed for different kinds of real-time transmission that were sometimes lossy, and it was okay that it was lossy. X25 tried to make sure everything got from the source to destination in the right order, which for many applications is exactly the right thing. TCP does that too. But we had to develop the user datagram protocol running over IP in order to handle packetized voice, packetized video, packetized radar. The radar system doesn't want to know where the missile was. You want to know where it is now. And so if you miss the packet from the radar system, you don't care. You just want the latest information you could get. That's not what the virtual circuits were delivering on more TCP. So people moved away from that over time as their appetites for different kinds of applications grew.
Okay. We'll now move on to our second topic of interest, the rise of AI. Okay. AI relies heavily on internet-based data. How do you see the relationship between the internet and AI evolving in the next decade?
Well, this is a very pointed question. I'm glad you asked, because there's some tension right now between the openness of the World Wide Web, where information is broadly available to anyone who can find the URL. And there is also a countervailing force saying, well, I want to control who has access to my information. Maybe I want to monetize it. Maybe I just don't want it to be shared broadly without my choice of who gets access to it. So there's some tension right now. I think that there will still be a strong motivation to share information freely. When the World Wide Web was first taking off, it was pretty amazing how many people just wanted to share what they knew for the joy of knowing it was useful to someone else. I sincerely believe that that is still a strong motivator for many people in the world. On the other hand, there are also people who understandably say, well, I want to control access to the information, maybe I want to charge for it, or I want some quid pro quo. And there's nothing wrong with having both of those practices showing up in the big tent of the internet. So there may be some diminished access to content without some sort of negotiation. But I do hope, frankly, that we still maintain this open academics. Think about Archive, which is the physics data site or publication site, has been incredibly important for the advancing the state of the art of physics, and now just as well, because content is freely available. And the fact that you can find it, search it, get access to it, great pace at which we're taken and the successes obtained. So we don't lose the utility of this open ethos, even though I'm sure there will be an increasing amount of content that is whose access is controlled in one way or another.
Yeah. Next one is many fear that AI could reinforce biases, spread misinformation, and even threaten jobs. What steps should we take to ensure AI benefits society as a whole?
Well, that's certainly a very good question. And so far, I think we could argue that AI has been very, very beneficial. I mentioned the AlphaFold result, for example, with the protein structures, but there are lots of other examples. People today are using large language models for writing software. For example, someone estimated that about 25% of the software that we produce at Google is being written now by these large language models. Of course, they get a lot of scrutiny by the programmers before they're put into use, because the automatons could make mistakes just like human beings do, and we have to be thoughtful about that. I do think that we should worry about abuses of the system. Misinformation and disinformation are easily produced by the use of these tools. And some of the tools even unintentionally produce misinformation. We call it hallucination, where you may have trained with factual material, but you produce counterfactual output because of the way the content is generated. Over time, I think we will learn what causes that effect and how to restrict it or limit it. But I think for anyone using AI applications in generative modes, it is well served by applying critical thinking to whatever that output is, especially if it's going to be used for some high-risk application like medical diagnosis, for example, or maybe treatment recommendations, or maybe financial advice. So for high-risk applications, people should be skeptical of the output until it's clear that the output is in fact valid. And of course, over time, I hope that we'll be able to use the same tools to do some of the automatic validation. And where did this information come from? What is its provenance? Is there corroborating evidence that the assertions that are being made can be validated? All of those are questions that humans should be asking, but maybe we can get our AI partners to ask those questions for us as well and reassure us that the information is accurate. So we're at the very early stages right now of what I would consider the AI revolution. Many, many more things to come.
What you mean? Yeah, can you hear me?
I'm still here.
Okay, all right. But
yes, I can.
Okay, what you just described is sort of AI policing itself, or policing the internet.
Well, I hope we can get it to do that, and until it can, then human beings are responsible for that, and each of us will benefit from AI. All kinds of reasons, in addition to looking at AI output. Here we go again.
Yeah, here we go again. Miss Siti, please mute. Yeah, can you mute her? Miss Siti. Tapi lepas tu pada tahun 2022 kita telah buat kemudian lah yang kita ada tambah beberapa polisi yang mana kita telah berbeza polisi tersebut. Tetapi kita tak ada yang final version untuk polisi di bawah Miss Siti. API lah. So harapannya okay.
Are we back?
Yeah, we are back.
All right, we're back.
Yeah. So what were you saying about AI policing the net and content?
Oh, well, what I was saying is that humans have to do this critical thinking right now because the AI processes we have not yet figured out how to make them self-disciplined. But I think we're getting closer and closer to understanding this. So, looks like we've got yet another interloper. This is fascinating, isn't it?
Interloper.
So anyway, I think eventually, however, we will be able to train the artificial intelligence bots to do a lot of their own validation and scrutiny. So it'll be an interesting exercise over the course of the next 5 years to see how well the AI systems can discipline themselves.
I was going to keep this question to the end, but since you brought it up now, this seems to be heading towards what we call the what was it, the Cyberdyne and Terminator.
Oh. Well, I hope not. But there is a lot of speculation about the extent to which these artificial intelligence multi-layer networks can be self-driving.
Yes.
I'm not speaking of self-driving cars, although
Yeah,
that's
yeah,
another
yeah, yeah,
amazing
yeah.
example. You basically give the car an objective, get me from point A to point
Yes.
B,
Correct,
and
yes.
then we figure out how to do that, and also how to negotiate all of the things that occur in
Yes.
between, like bicycle riders and pedestrians and so on. So we're not too far away from asking other artificial intelligences to do things for us. The most exciting thing that's happening right now is AI agents that are capable of interacting with us, taking on tasks, interacting with other artificially intelligent agents in order to accomplish an objective. This could be very exciting, but it could also be very scary.
Yes.
And part of the reason that it's potentially scary is that if we use natural language as the way in which we communicate with the artificial agents, and the agents use natural language to interact with each other, in the same way that humans can misunderstand each other, the agents might misunderstand each other. In case they will go off and do something that we did not intend for them to do.
Okay.
So we still have some work to do to find a way of inventing a vocabulary for the AI agents to use that will not suffer from ambiguity. And we need, for the agents to interact with each other in an unambiguous way, and they also need to have a way of confirming between themselves that they both understand the same thing. And I'm not an expert in inventing the languages that might be needed, but I'm sure there'll be some controlled vocabulary with well-defined semantics that we will want to introduce into this equation, so that the automated processes are less likely to go off and cause things to happen that we didn't intend.
In this sense, do you suppose Isaac Asimov's 3 laws apply?
A number of people have proposed something like that. By the way, there's a 4th law. If you've read a number of his books, there's the 0th law in addition to 1, 2, and 3.
What is that?
And people have proposed similar kinds of things that we would like to be true. In other words, we would like to design and build these artificial intelligences that have boundaries that they won't breach. Now, I don't think we exactly know how to do that yet. And I'm sure part of it has to do with the kind of training that we do. But I know that there are many, including in my company at Google, who aspire to finding ways of achieving that objective.
Okay. All right. Shifting gears a bit towards a bit more politics. The US and China are investing heavily in AI, but with different philosophies. China focusing on centralized control and state-led initiatives, while US relies more on private sector openness innovation. Which model do you think is more likely to lead to artificial superintelligence? And what are the implications of this superintelligence?
So we're back to the Terminator again. Well, look, first of all, those two practices can both can be quite effective. I mean, if you have central control, you can steer the direction of the research and the development. You can, in the private sector, there's a kind of a steering, but it's not quite as top down. It's often driven by who can afford to do what. And the private sector, of course, has been investing very heavily both in AI computing capability and also communications capability, because in many cases you need both in order to do the training and to get access to the data that you need. My guess is that both of these methods will yield some pretty powerful results. Whether or not we end up with a super intelligence is a very interesting speculation. I know that at least one of my colleagues at Google is anticipating that a singularity will occur somewhere in the 2029 or 2030 period, at which point the intelligences will be smarter than we are. In some ways, they already are. I mean, think about a language translating system, which we use heavily at Google. It speaks 200 languages and has the ability to translate between them with varying degrees of fidelity. That's more than any human can do, as far as I know. So there are instances where these artificial intelligences have capacity that could be called superhuman. On the other hand, people still have an amazing ability to juxtapose ideas in ways that are creative and innovative. But I wouldn't be surprised to see the artificial intelligences doing something along those lines. Some of my colleagues use these generative AI systems just to get ideas going, sort of a brainstorming assistant, if you like. And even if some of the ideas that come out are inappropriate or are not useful, the interaction with the intelligent AI system might generate ideas that you wouldn't otherwise have explored. So there could be some very powerful results coming out of the human and AI interactions.
On that note, Doc, there's a question on the chat. Do you think we need a global body to regulate AI development similar to how internet was standardized?
Well, that's an interesting question. I think that these are very powerful tools, and they have the ability to, let's amplify human action. That's already true for a lot of non-AI capabilities as well. And so given this amplification capability, if that means you can amplify bad behavior, that's a serious problem. And so I'm pretty sure that there will be, I don't know that there will be a global body. I think it's much more likely that there will be intergovernmental agreements about monitoring and intervening in the event that these tools are being abused. And we see this already in other dimensions. Look at the drug concerns, for example, trying to limit the flow of harmful drugs across borders and trying to track down people that are trying to either make them or deliver them. So I wouldn't be surprised to see some intergovernmental cooperation along the same lines to keep the artificial intelligence systems from becoming hazardous.
Okay. There are a few other questions on the chat, but I'll reserve them to a bit later because they're a bit off topic. I'll carry on. Internet helped accelerate globalization, but with AI, we are now seeing fragmentation of cyberspace due to different regulatory and business approaches. Do you think internet and AI will continue to diverge into separate digital ecosystems?
No, I don't think so. I believe that the two are kind of bound at the hip. The internet is how you get access to the AI agents. Of course, at some point, AI agents will be local. We're already starting to experiment putting special purpose hardware on mobile phones, for example, to perform the AI operation literally without having to go out onto the internet. We do language transcription, for example, can be done with a mobile phone. And increasingly, we're able to do that without actually having to go out to the internet and come back. On the other hand, the internet is such a powerful tool for interaction at a distance that a great deal of our applications are still going to require exchanges across the internet. Think about all the various transactions that we do today, even e-commerce, for example, if it's still called that, requires that the data be transferred across the net in order for two parties to come to some agreement. So I don't think that they will be separate. I think that they will still be very closely connected with each other.
Okay, there's one question on that AI note. Could you elaborate on how AI is influencing the Internet Protocol standard development process, particularly within the IETF framework? Specifically, how might AI streamline or challenge the collaborative and iterative nature of protocol design and implementation?
So I would guess that a couple of things are likely to happen. The IETF develops standards, and it would not be out of the realm of possibility that an AI agent could be used to help develop new standards and new protocols, or in order to accomplish a particular objective. So I would imagine that the AI systems would simply become partners in the exploration of and development of new communication standards that could be used in the internet. So I'm actually looking forward to that kind of help, to be honest with you, because it might accelerate our ability to build new capabilities into this online environment.
Okay. Could you share your thoughts on ICANN's Universal Acceptance Initiative and how AI can play a pivotal role in addressing technical barriers to achieve a more inclusive and multilingual internet experience?
Well, it's certainly clear that we already have found that the AI systems help us with doing language translation, which will help us communicate with each other better in our preferred native languages. Hopefully, without losing accuracy. I mean, that's always a big issue about. Remember that movie called Lost in Translation?
Yeah.
So there's always the risk factor there. My impression is that the translations are getting better and better over time, and they could certainly facilitate multilingual exchanges among people who don't have a common language in which to have a discussion. And it wouldn't surprise me, although I don't know that anyone has actually done this, the development of protocols and their specification might turn out to be amenable to AI application in the same way that programming is becoming something that an AI can do for you. So if you were to say, I need a protocol that will have perform the following functions, it's conceivable that an AI helper might propose something that would be beneficial for you. I don't know that anyone's actually done that yet, but if you can do it for programming, why not do it for protocols as well?
Okay, all right. Okay, shifting gears a bit now to quantum computing. Given the potential of quantum computing to be secure while simultaneously being faster than currently possible, do you foresee a change for the internet? And definitely will enhance AI. Will this lead to an arms race?
Well, let's see. Let's start out with, there is a quantum threat against security, as everyone knows. The algorithms that were very popular and developed in the late 1970s, the RSA algorithm, for example, they were all based on the difficulty of factoring the products of large primes. Shor's algorithm for a quantum machine is a way in which factorization can defeat the work factor by speeding up the ability to do factorization. This has already been recognized for quite a while now, and the National Institutes of Standards and Technology in the US invited quantum-proof cryptography to be proposed, and some 36 algorithms were proposed, of which about 4 or 5 have now been adopted as proof against the quantum breaking of the older algorithms. And we've already started implementing those post-quantum algorithms at Google, knowing that our customers often want information to be protected for at least 25 years. And it's a reasonable bet that quantum computing by 25 years from now will actually be readily available and quite powerful. Now, the other side of the coin is that quantum computing may turn out to speed up a lot of optimization calculations that might be impossible to do using conventional computing. And I'm very excited about that possibility. It might conceivably speed up some of the speed up some of the machine learning algorithms as well, although I'm feeling a little unsure about that answer because I'm not expert enough to know which quantum algorithms, if any, have been turned up that would enhance the rapidity of machine learning structure of multi-layered.
So I think something wrong with the
Internet.
Vin,
For Win.
yeah,
Okay.
internet line.
Okay. I thought it was my side.
No, I think we can monitor the bar at the bottom left on your screen that shows the internet
Okay, Win
quality.
is out.
Yeah, I think Vin's internet is not really
Yeah.
stable right now.
Yeah.
Sometimes white, sometimes yellow, and then go to red. I think it's bad one. So I think he's out right now, right?
Yeah, he's out. Yeah.
Yeah, we'll wait again.
Yeah.
Yeah, hello, Vin.
Hi, Win.
Yeah,
Sorry about that.
yeah, I think
No,
your internet line. Yeah.
I'm
Yeah.
back again.
Yeah, I think I know what happened. AI kicked you out.
I hope that there's no Trump tariff about the internet.
Well, I think I'm in a hotel right now, and of course, there's no guarantee that it's
No issues,
internet
no issues.
particularly great.
Yeah, but we did have a good 1 hour uninterrupted.
So we did. Well, I hope that was satisfactory for you, and I certainly enjoyed the questions, and I would certainly be happy to do that again if you're interested.
But before before we say bye, can I just read off something here? I'm curious, does the dark web really exist? How deep does it go beyond the common internet search engines that exist today?
Well, it absolutely exists. There's no question about that, and it's no different than the regular internet. It's just that people go out of their way to try to hide where those websites are. They often use what's called the onion router or the Tor network in order to obscure where the websites are. But it's a serious problem, and there are people and companies that monitor what's going on there in hope of protecting people from potential hazards. If you go into the dark web, you should be very thoughtful about what equipment you're using and what kinds of software protection you've introduced, because there are people who are very interested in attacking and taking over control of your computer, or just stealing information from it that they can use later on. So the internet has become a potentially dangerous place, which is why accountability is so important. And also agency in the sense that people need to have tools for protecting themselves. So that's why we have cryptography end-to-end. That's why we have two-factor authentication. That's why we teach people about the risk factors of being online. You know, in the United States, before a teenager is given the keys to the car, they have to take a class and pass a driver's test. And I've been thinking maybe we should have an internet driver's test where people can show us that they know what the risk factors are and they know how to use the internet safely. I'm not literally suggesting there should be an internet driver's license, but the concept behind it is to teach people what hazards there are and how to be safer.
On that note, Vin, I'm curious on a teaching point of view. How do we encourage reading? Is reading a book still relevant? Because what I see and as the research from either Stanford or somewhere prove that people are less their focus span has become shorter because of the flicking Instagram and all that stuff. So
yeah. Yes. Henry Kissinger and I had lunch some time ago.
Okay.
And I remember he complained a lot about the internet. He said that he was unhappy because people on the internet were happy with a 2-paragraph answer, but he was writing 700-page books.
Exactly.
So I think the medium by which people ingest information may be changing. A lot of people prefer to go to video, for example.
Yes.
And for many situations, that's a perfect medium. I mean, it can be illustrative, for example. On the other hand, I still love curling up with a good book.
Yes.
And I still find that to be a very useful medium. But I wouldn't rule out some of these other ways of interacting. Think about interacting with a large language model. Sometimes that's a very interesting way of discovering things. Instead of marching through a predetermined by the author sequence, which the author thinks is the best way to present this, it could very well be that the interactive method produces better learning because you're learning what you're interested in at the moment, as opposed to reading something and wondering why you're reading it, because you don't know that you're going to need it later on.
Okay.
So a lot of these just-in-time learning situations can sometimes be more reinforcing than a conventional way in which we've been taught to learn, which is to pick up a book and read it from beginning to end.
That does make a lot of sense, yeah.
So I hope you'll forgive me, but it's 11 o'clock here.
Yes,
and
sure. Yep,
I have
understand.
a morning meeting that
Yes,
I
sir.
have to do.
Yes, just before we let you go, we'd like to take a picture with you and all the
Okay, we can do that.
available, all the people present here. Okay, guys, could you switch on your cameras? Thanks, Quack, for joining us. Okay, guys, cameras. Mr. Goh, Mas Jamila, Nazri. Oh, okay, Nazri is in. Cameras, please. Shah, whenever you're ready.
Okay, ready.
Second page, third page, not many people opening cameras. Guys, cameras. Thank you. Thank you for joining us. Thank you for making this a good day.
Thank you, Prof.
Thank you.
Thank you very much.
Yeah.
Thank you.
Okay, thanks, Vint. Thanks for joining us. Thanks for gracing our Isaacs Series 22. Very good evening, good night to you. And we hope you will be in touch with us.
I hope I have a chance to visit you in person.
Yes, please.
I would look forward to that. I've been in Malaysia before, but it's been some 20 years at least, I think, since the last
Oh, okay.
time.
May I ask what was the occasion?
I would look forward to that. Anyway, see you on the net.
Bye.
Yeah. Bye.
Ciao.
Thank you.
Good night.
Bye.
Good night.
Bro.
So the attendance,
Oh yes, attendance, please. Yes, guys, don't
QR code for the attendance.
don't click off. Get your attendance signed in. Nazri, is there a separate code for Unimap? Azarul, where's the attendance link? Mr. Gig Hong Yak. You from industry?
No, I'm from University of Wollongong, Malaysia.
Wow, Wollongong. Okay, all right.
Okay.
Thanks for joining. All right. Okay, bye.
Oh, well.
Thanks, Doc. Thanks, Doc.
Syah, boleh letak attendance link tak dalam chat? So you baca tadi semua berapa? Dia punya soalan dekat Zoom.
Zoom, I think I miss satu je kot.
Okay.
Zoom, I miss Quack punya question. Can you say something about current space data, lasers communication?
Okay.
Itu je I miss. Kita punya soalan pun last question terlepas lah. Last two questions.
Okay. So dia dekat Michigan right now. Dia ada
Michigan. Michigan.
teruk juga internet US ni. Atau internet lebih kurang kita lah.
Bukan internet US, internet hotel lah.
Ya, US punya lah.